We are going to start with introduction to vectors. Introduction of vectors. Vectors are actually when we are focusing on vectors at a basic level, at a shallow level, we have to first talk about physical quantities. Okay, so there are two types of physical quantities. Okay, there are scalar quantities and vector quantities. We can divide. We can divide physical quantities into two types. One of them is scalar, and the other one is vector. And here our focus is on vector. But let's talk about scalar first. Scalar quantities have only magnitude. They have only a magnitude. What is meant by a magnitude? They have a value. For example, time, mass, distance, speed. These are called as scalar quantities. Okay, you can't say a direction. You can't set a direction to time. You can't set a direction to mass. Okay, and distance, we can't fix the direction for distance, especially for the speed. And this can be written as, this can be understood as, if someone say, okay, if someone is traveling in this direction in 40 ms minus 1, the speed will be 40 ms minus 1. Speed will be 40 ms minus 1. That's all you need to speak about speed. Okay. And if they are traveling in the opposite direction, still the speed will be 40 ms minus 1. There is no change in it. But vectors, they have magnitude as well as direction. They have magnitude as well as direction. What do I mean by that? Well, here, let's look at some examples first to understand this. So we have displacement, velocity, acceleration. These are some of the examples for vector quantities. These are some examples for vector quantities. And we have to keep in mind that we have to talk about direction as well as magnitude whenever we are writing a vector quantity. And we can also say about force. Yeah, force is also vector. So let's say someone is applying a 50 Newton force in the right direction, then the force will be equals to 50 newtons towards right. Keep that in mind. And if someone, let's say this is mentioned as plus 50 Newton, well then, if they apply the force in the opposite direction, well then the force will be negative 50 Newton. This is the magnitude, and the sign here, the negative sign here, minus sign here represents the direction. That's the important thing that we have to know when we are talking about vector quantities. Okay, you can't just say 50 newtons. You have to mention a direction. Either you can mention positive 50 newton, or you can say 50 newton in the right direction. You can use this. Okay, or you can use another way, and that will be discussed. Those will be discussed in the upcoming videos. Okay, so let's continue. So how are we representing vectors? Well, in this case, okay, whenever I'm tutoring something new to you, I will try to start with two-dimensional plane. What happens in a two-dimensional plane? Because it is easy for us to imagine what happens in a two-dimensional plane because we see things in two-dimensional plane. Okay, we normally see a length and a height. That's what we normally see. Okay, length and a breadth. Okay, so that doesn't matter what you call it, but you normally see things in a two-dimensional way. Now you are seeing this studies. Okay, the thing I'm teaching in a two-dimensional thing. Okay, it's not in 3D for you. Okay, and it's easy to visualize in 2D and then generalize it and come to 3D so that we don't have to spend time visualizing in 3D. I'm not saying visualizing is a bad thing. I'm just saying visualizing in 3D is really hard. So we'll start with 2D and work our way up to 3D. That's what I'm saying. So in vectors, we have to talk about the representation of vectors, how we represent vectors. Okay, representation of vectors. Well, this one most of you must know. Okay, so we have 2D representation. Here we will use only a straight line with an arrow. A straight line with an arrow. Okay, so you can write this down as vector. There are multiple ways of writing the vector. Okay, I'll just give you the first of all the numerical form of writing the vector. So here we can see it's going in the right side direction and it's going upwards. Okay, we have to talk in 2 dimensions. Yeah, so we have to talk about the x-axis, how much it's moving, and in y-axis, how much it's moving. All right, so that's how we talk about vectors. So I can say, let's say this is in 2D. I'll mark it here 2D, and let's say this is x-axis, and let's say this is y-axis, and this is the origin 0. Okay, so if this is who knows 7 units, and let's say this is another 7 units. Okay, so this vector can be written down as 7 7. This one represents the first digit in the column, represents the x-axis value, the x-axis coordinate, or whatever the thing you want to say. Okay, x-axis coordinate, and this one is y-axis coordinate. Okay, so this is how we normally represent vectors in 2-dimensional plane. Okay, in a 2-dimensional plane, we represent vectors like this. Okay, so you might have some doubts, and I'm gonna clear them. What about this? What about this? Is it the same 7 and 7? Well, you have to think about the direction when we are speaking about vectors. Ilaya, that's very important. So look at here. If we start from here and we have to go here, okay? So let's talk about, first of all, let's talk about the horizontal direction. In which direction are we traveling? Well, we are traveling in this direction. And vertically speaking, we are traveling in this direction. We know normally, conventionally, upward direction is positive and towards right is positive. But in this case, all those things are different because we are going towards left and we are going downwards. So we can say we are moving 7 units in the opposite direction, the negative direction here. Okay, we are moving 7 units in opposite direction, in left direction, and 7 units downwards. Okay, which means downwards 7 units can be rewritten as upwards -7 units. Similarly, to the left 7 units can be rewritten as to the right -7 units, because these two cancel each other out to form this one. Okay, so this one should be rewritten as -7 -7. Why? We are moving -7 in x direction and -7 in y direction. Okay, so this is the representation of vectors in 2D. All right, let's do some examples to understand, to have a clear understanding on this idea. Okay, let's say the vector looks like this. Let's say the vector looks like this. Okay, and in x-axis, okay, in x-axis, okay, in x-axis it is moving five 5 units, moving 5 units. This is the 5 units in x-axis. Okay, well then, how can we represent this? I mean, how can we write it in the numerical form? Well, it's easy. Think about what we learned. We know the first digit in the column, we should represent how much it moved in the x-axis, and the second digit in the column is to say how much it moved in the y-axis. The vector moved in the y-axis. Here we know in the x-axis it has moved 5 units, and in the upward direction or downward direction, has it moved at all? In that time, in that direction, has it moved? No. So you can say 0. It has. So you can say 0. Similarly, if the diagram look like this, only in y direction, okay, only in y-axis direction. Let's say it is 3 units. Well, it's not 3 units, yeah. scale. It's not up to scale, okay? It's not up to scale. So let's say this is in 3 units. How can we write this down? Well, we know it has not moved in x-axis, so it is 0. And then it is moving downwards only. And it moves 3 units. So you can say -3. This is how we numerically represent matrices. Okay, this is how we now numerically represent matrices. Numerically vectors. This is how we numerically represent vectors. And the important thing about vectors, okay, an important thing about vectors that we all have to keep in mind is, if you draw a vector like this, okay, if you draw a vector like this in the two-dimensional plane, okay, in the two-dimensional plane, and let's say you're drawing another one, you're drawing another one here, and you're drawing another one here, and you're drawing another one here or here. My point is, wherever you draw the vector, okay, wherever you draw the vector, it doesn't matter. It doesn't matter. All these vectors are equal. All these vectors are equal in a 2D plane. If you draw like this, position vectors, they have different rules. They have different set of rules. I'm not talking about position vectors. I'm talking about normal vectors. In a specific plane, if you draw vectors like this, they are equal. Wherever you draw them, it doesn't matter. They are equal. Okay. And let's say this is 5 comma 6. Well, this will also be 5 comma 6. This will also be 5 comma 6. This will also be 5 comma 6. And this will also be 5 comma 6. And what about if we change the direction? If we change the direction, what happens? Well, if you change the direction, it will be -5, -6. Why? It's exactly moving opposite to the direction that we have drawn these vectors. Okay, I haven't written down the notation yet. I'll explain the notation in an upcoming video. But for now, you have to understand that vectors are the basic vector ideas that you have to implant in your brain. That's very important. Okay, so this is how we represent vectors in 2 dimension. What about 3 dimension? Shall we move to 3 dimension? Well, in 3 dimension, as the name suggests, a 3D plane has 3 planes. Okay, we normally draw these planes like this. Layer. We normally draw these planes like this. All 3 planes will be 90 degrees to each other, pi by 2 degrees. They will be perpendicular to each other. They will be perpendicular to each other. And we know this, if this is x, this will be y, and this will be z. And this is the origin 0. So in 3 dimensions, if we have to mention a vector, it is really hard to draw, okay? But I'll try to explain it, okay? I'll try to explain it. Let's say there is a vector called, okay? Let's say there is a vector called 4, okay? 4, 3, -2. 4, 3, -2. Okay? As in 2D vectors, okay? As in 2D vectors, we know when there were two numerical values, we knew the first one was for x-axis, the second one was for y-axis. Here also the same thing. Okay, here also it's quite the same. We use this for x-axis, this is for y-axis value, and this one is for z-axis value. Okay, so I'll draw one by one. Okay, I'll draw one by one. Okay, I'll draw one by one, and I'll meet you after I draw this. So, since we are talking about 3 different planes, I have drawn these 3 planes so that it will be easy for us to understand what actually happens behind the 3D representation. Okay, so here you can look. We have 4 units in x direction and 3 units in y direction. So I can say we are moving 4 units, and here we are moving 3 units. So it must look like this. So it must look like this. If we start from the origin, it should look like this. Okay, so like this. Okay, and let's say we are moving in x direction. Yeah, obviously we are moving x direction. We are moving 4 units, and in z direction we are moving 2, but in the opposite direction. Well, that's good. It's great. It's amazing. So we have to draw it downwards also. Okay, and done. Okay, now we can draw that. So here it's moving in negative direction. So I can say -2. So I can draw an arrow here, and we will be good to go. And in the YZ plane, okay, we have 3 units in the Y direction and -2 units in Z direction. So that is also done, and that is also done. And the combination of these three will be the X, Y, Z axis. Altogether, we can represent this in the 3D plane. Okay, so how am I going to do that? Well, I'll draw that for you again. So we know this is the x-axis, this is the y-axis, and this is the z-axis. We know the vector that we are going to represent is 4, 3, -2. So in x-axis we have 4 units, and in y-axis we have 3 units. So it should come somewhere here. So I can connect these 2 points to see which plane this specific vectors fall under. And then we have -2 in z-axis. So I can say it should come somewhere here like this. Yeah, but it's going downwards. I don't know how I can show that. So I'll just put -2 here, if you don't mind. Okay, I'll just put -2 here. So it should come in this specific line. Okay, in z-axis, it should come in this specific line. Okay, and we know -2 is somewhere here. Okay, which means -2 is somewhere here. So the vector will look like, okay, in this 4, 3, the vector will look like here. It should go from here to here, from the origin to here. Okay, so this is what happens. But I don't know whether this will confuse you, so I will draw until here. Let's say it is in the -2 in the z plane. So that's the issue here. We can't actually visualize 3D. Okay, it's really hard to visualize in 3D. That's why we talk in 2D and work our way up to 3D. We generalize for 2D and we apply that equation for 3D also. Okay, that's how we normally do. Now, before going further, I'll just introduce you the notation of vectors. Okay, I'll introduce you to the notation of vectors because that's very important. So we have the notation of vectors. So if you draw a vector like this, you can represent this in multiple ways. You can say A, B. Okay, you can say A, B, and you can say this is the vector A, B. Or you can write a single letter. Okay, a single simple letter like this, A. Okay, you can write like that. You may think, why am I underlining this? Well, to show the vectors, the variables, the difference between vector variables and other variables, we used to underline that. Okay, but in text form, in a typed textbook, you may see the bold term. Okay, the bold term. That is also acceptable, but I don't think you're going to waste time bolding in your exam. Okay, so that's why we normally underline to show this. Okay, so I can say this is equals to who knows, 4, 3, -2. Okay, this may not look like that, but it is 4, 3, -2. We can say that is 4, 3, -2. Okay, and I said this is x-axis, this is y-axis, and this is z-axis. But normally when we are speaking about vectors, we don't talk x, y, z. Instead, we speak about I, j, and k. Just the letter changes, but it's literally the same thing. Okay, it's literally the same thing. So here you can write this as 4i plus 3j minus 2k. This is how you have to write this vector. If you're performing, you are going to write in this format. If you're going to write in this format. Okay, so these are the basics of vectors. We looked at the introduction to vector, and how we can represent vector in 2D and 3D space. And now we know the notation of vectors. Okay, now we know the notation of vectors.
Thanks for watching the first video in our vector series. If you found this introduction to vector representation and notation helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.